This videocast deals with adding and subtracting significant digits. Our objective is to identify the number of significant digits in a value, round the value to the correct number of significant digits, and also add and subtract significant digits. When adding and subtracting significant digits, the first rule is to make sure all numbers are added together. This is very simple to do. Take all the numbers, add them together, and come up with an answer. Then the second thing is to round to the position using the number with the fewest decimal places or smallest available position. This can be somewhat confusing, so I have three examples here to sort of help us figure out the problem. In all three of these situations, we have already added the numbers together. The easiest thing to do is to add them sort of like what you did back in elementary school. Put them in the correct positions. So in the first case, you have 18,400. And you're going to add 7,420 to it, and you come up with 25,820. The next number is 172.233 plus 18.22432 plus 3140. And notice that after that zero, there's a decimal point, meaning that zero is significant. And we have our answer there. And then the final one is a subtraction problem. In each one of these cases, we just simply put them in the proper order for adding them, coming up with an answer. So the question is, what is our final answer going to be? For this first problem, we notice that in number 18,400, the 400, that 4 spot, is the last significant digit listed. And this is what's meant in the previous slide when we talk about you want to try to find the spot with the lowest position available. In the number 7420, that too is significant, but since we have the 184, those last two zeros are not significant, meaning that they haven't been measured, so we do not know what those values are. How can we add 20 to two numbers that we don't know what those are? So in this result here, we have two zeros, we don't know what those are. If we add 20 to whatever these are, we don't know with certainty what we're going to get. So we add it as normal, and we come up with this 2 here. And so this 8 then is our guess, just like this 4 here is our guess. We are 100% certain that this is a 1 and 8. This 4 is a guess, and then we have no idea what these zeros are. This 7 we're 100% certain on. This 4 we are. The 2 is our guess. And then, of course, this 0, we have no idea what that number is. So since we don't know what this 0 is, what this value is, we cannot use it in our addition problem. So we take this number and we have 25,820. This 2 then tells us that this 8 needs to stay the same. So our final answer here would be 25,800. Now in this next problem, we can go all the way out to the thousandth of a digit, and then we have the 100,000th of a digit as well. But this one here, we stop right after the 0. Now this decimal point means that this 0 has been measured. It is our guess. So since this number is a guess, we can't use anything after it because we have no idea what this number is. It is a guess. So therefore, when we take a look at this problem, we have to cut everything off after that 0 because this is our first guess that we get. We have a 3 here, that's a guess. We have a 2 here, that's a guess. So everything else needs to be cut off. In this case here, the 4 tells us that that 0 needs to remain the same, so we put 33, 30. And then we put a decimal point at the very end. And the reason why we put the decimal point here is to show that that 0 is indeed significant. It has been measured. In our final problem here, we're missing 2 zeros here, but that's because they haven't been measured. We can't put zeros here because if we did, since there's a decimal point present, those 2 zeros would be considered significant. So those 2 zeros are not there, meaning that they are not significant. However, this 0 has been measured. It is our guess, which is why it's listed here. It's a significant digit. Now, when we take a look at the numbers down below, the 0.024000132, this 2 is now our guess. So when we go to subtract them, we have that 0, and that 0 in the top is our guess. So therefore, we cannot use any digits after that. When we take a look at it, we have this 6 here, and this 6 tells us that 9, or that 8 now needs to round up and become a 9. So our final answer would be 0.028849. This is how you add and subtract significant digits.